Hi everyone, this is Dr. V.S. Nishak from EC Department, SNS College of Technology. Here we are going to see the topic Introduction of Operational Amplifiers from the unit Operational Amplifier Characteristics. In this video, we are going to see the topics what is an operational amplifier and why we study the operational amplifier and the characteristics of operational amplifier and its configuration, applications and summary. Okay, so why or what is an operational amplifier? Why we need to study the operational amplifier? The operational amplifier is an integrated circuit that can amplify weak electrical signals. So if you see any other amplifier, it provides amplification, but the gain provided by operational amplifier is much more greater than the gain provided by the any other amplifiers. So that is the main use where why we are using operational amplifier in any kind of electronic circuits. So that is the purpose of the operational amplifier, which is widely famous. So it has two inputs and one output. The purpose of operational amplifier, it is originally designed for mathematical operations like addition, subtraction, integration, differentiation, etc. And some other uses like amplifiers, filters, oscillators, comparators, waveform generators. So there are more applications we are having under the topic operational amplifiers. So here we are seeing the uh, symbol of the operational amplifier with two input signals. So as discussed in the previous slide, two input signal and one output. So one input is a inverting input that is connected with the negative input terminal, and another one is called as a non-inverting input, that is a positive input terminal. And we are having the two power supplies, plus VCC and minus VCC. Why we study op amp? So because of its versatility used in nearly all electronic devices, foundation of electronics helps understand advanced analog and mixer signal designs applications. It is mainly used in audio systems, communication devices and control systems. Anatomy of operational amplifier. So we can see the block diagram of the operational amplifier now. So if you see, it is divided into four main blocks. So initially it starts with input stage, then intermediate stage, that is otherwise named as a gain stage, and level shifting stage and output stage. So that is discussed here in this slide. Input stage, the differential amplifier is utilized for high input impedance, and the next intermediate stage is otherwise called as the gain stage, that amplifies the signal further for providing much far better gain. And then we are having the level shifter stage and finally output stage. So these are the four main stages of the internal that is operational amplifier IC741. And then coming to the pin configuration, so as discussed in the symbols, we are having mainly input pins, output pin and then power supply pins. So here in this diagram we can see the IC741 pin diagram starts with dual inline package. So that is offset null number 1, pin number 1, and pin number 2 is a inverting terminal, pin number 3 is the non-inverting terminal, and pin number 6 will be the output, and then pin number 5 will be the another offset null, and the supply, positive supply is connected to the pin number 7 and negative supply is connected in the pin number 4, and there is no connection in the pin number 8. So this is the simplest pin configuration of the IC741. And then coming to its characteristics, so in the ideal operational amplifier we are having input impedance is infinite and output impedance 0, open loop gain infinite, bandwidth infinite, slew rate infinite. So everything is infinite other than the output impedance, so that is equal to 0 in the ideal stage. But going to the practical stage, so practically while we are connecting to any circuit, we can find that input impedance of the op amp will be very high but not infinite. Output impedance is low but not accurately equal to 0. So like similarly, open loop gain will be finite and bandwidth will be limited and slew rate also limited. So this is the main characteristics of the operational amplifier in the ideal condition and also in the practical condition. So we can prefer only the practical characteristics. And coming to the configuration, okay, we have seen the symbol and block diagrams. So here we are connecting the input to both the terminals. Since we are having two input terminals, we are connecting input signals, AC input signals, to the both the terminals. V1 is as the V in one input and V2 is the another input. So that is connected to the two input terminals, and output V0 is obtained from the operational amplifier. So here, based on the configuration, the operational amplifier is classified into open loop configuration and closed loop configuration. Open loop is nothing but operating without any feedback from the output to the input terminals. So best example is comparator circuit. Coming to the closed loop configuration, we can see the below diagram. The V out from the path, output path V out, we are taking a signal. So that is taking a connectivity between the V2 and V out, input path and the output path, with a resistor RF. So that is nothing but a feedback path. So this is, if the feedback path is available between the input and output, so that is called as a closed loop configuration. These are the two types of configuration we are used widely for any sort of applications of the operational amplifier. And then coming to the applications of operational amplifier, we can find out the gain of the operational amplifier with the help of the inverting amplifier and non-inverting amplifier. If the input is given to the only to the negative input terminal, so that is called as an inverting amplifier. And if the input is given only to the non-inverting terminal, so that is called as a non-inverting amplifier. And the formula for finding out gain equal to V out by Vn, which is equal to minus Rf by R1 in the case of inverting amplifier, and V out by Vin will be equal to 1 plus Rf divided by R1 in the case of the non-inverting amplifier. And real life examples where we are using the operational amplifier, which is mainly used in audio amplifiers, filters, voltage comparators, sensors, etc. So in this video, we have discussed about the basics of the operational amplifier. We have seen what is the purpose of operational amplifier and what is the symbol, and we have seen what is the characteristics in ideal stage and practical stage. And then we have seen about the different applications where we are using this operational amplifier. And then what is the gain equation if the input is connected with the inverting terminal and in the input is connected with the non-inverting terminal. So those basics, every concepts that deals with the operational amplifier we have discussed in this video. And finally, we are here for the assessment based on the topics. What does an op-amp do? It amplifies the signal with high gain. Which of the following is an ideal op-amp characteristics? Okay, the given everything is a right answer. What is the gain formula for non-inverting amplifier? The gain formula will be 1 plus Rf by R1. In an op-amp, the term slew rate refers to the maximum rate of change of output with respect to the change in the input. So that is the right answer. And what is the primary use of the IC741? So it is for signal amplification. So from the initially we are discussing that it converts the weak signal into the strong output signal with high gain. So that is the main purpose of the operational amplifier. Okay, that's all. Thank you for joining this video. We can join in the next video.